Between group multi-factor designs. So in this presentation, what I want to cover are still between group designs, just like we've been talking about, where the individuals in the study are assigned to one treatment group only. And but this case, we're going to be looking at multi-factor designs. So instead of comparing one factor among the participants, there are two factors of interest here. So in a between group factorial design, a multifactorial design, subjects are going to, again, be typically randomly assigned to one factor and another, or we could have one of the factors or both predetermined. So we might want to look at the effects of gender within soccer players by position. So we would have two factors. One factor would be gender with two levels, male and female. Another factor, which would be soccer position, which could have obviously multiple levels depending on how we break them up. We also could do it as a treatment. We want to look at soccer players by position and three different training programs. And again, we could then have two factors, each with multiple levels. So in a factorial design, a multifactorial design, we have two or more factors. And these studies can get pretty complicated because not only are we going to look at the main effects of the factor, we're going to look to see if there are interactive effects between the factors. As I mentioned at the beginning or the first presentation in this series, you might look to see, does a person's gender affect them differently in how they respond to a treatment program? Or does the soccer position affect people differently? Do forwards respond differently to a training program versus defense players? And so on. So in a multifactorial design, we have two or more factors are studied, and those factors can have three or more levels within them. If differences are found in the treatment groups, then often we have to do additional testing. So if the initial ANOVA comes back as a significant difference, we often have to do what are called post hoc tests. That's Latin for after the fact. Post hoc tests to see where the differences exist between which groups and so on. So again, let's take a look at a couple examples of between group multifactorial designs, because I think that gives a better example and explanation of what this type of design looks like. So this study is called The Effects of Sprint Training with and Without Ball Carry in Elite Rugby Players. So these individuals had a very specific question. They wanted to see if training sprint training while carrying a ball affected their ability to sprint with and without a ball. So again, and they looked at this in rugby players that played positions that carried the ball or did not carry the ball. So let me draw this out a little bit more in detail. So this is how the researchers set up this study. They began by taking this group of rugby athletes and dividing them into two subgroups. A group of players by position that frequently will carry the ball, and then a group of players who by position typically do not carry the ball. So again, those of you that are familiar with rugby, similar to football, there's some people that typically will run with the ball, others that do not. Again, you never know when they may have to if they pick up a fumble or whatever you call it in rugby. But there still are the group of people that work with the ball and some that don't. Now, one question is, if they're used to running with the ball, should we train them running with the ball or should we not? Or does it even matter? And that's what they were trying to get at with this study. So the ball carry group, they had them train with the ball. They split them in half, had half of them do sprint training with the ball, half do sprint training without the ball. They also took the non-ball carry group and had half of them do their sprint training with the ball and half, again, without a ball, with the idea of being able to determine if it matters if we train with or without the ball. they took a number of different measures in this study because, again, they may the focus could be, is it only helpful in a short sprint? Does it matter for a longer sprint, and so on? So they took a number of different measures with these athletes before and at conclusion of the training program, which I think was 6 weeks, and they measured their 10-meter sprint speed, their 20-meter sprint speed, their 40-meter sprint speed. And then they obviously took these times pre and post, and they measured their sprint speeds at 10, 20, and 40 meters, both with the ball and without the ball. So they, again, if I train with the ball, am I faster running with the ball or without, and so on. So again, a pretty interesting kind of a practical study trying to look at how much this really matters, training with or without the ball, to see what we should do practically when we're working with individuals like this. So what did these researchers find in examining these rugby players? Again, this is a multifactorial design because we had two factors. The first factor being which type of rugby player were they, ball carrying or non-ball carrying. So it was factor one had two levels, and it was based upon ball carrying position. The second factor was the training program that they did, and the training program was either training with a ball or training without a ball. So this is a between groups because each subject only fell within one of those four kind of combinations of categories, and multifactorial because we had two factors: the position that they play, ball carrying or non-ball carrying, and training group, training with the ball, training without the ball. Often you'll see this called a 2x2 design. In this example would be a 2x2 design because we had one factor with two levels and a second factor, which was treatment group, with two levels. So it's a 2x2 design. What were the results? The results we see here within the ball carrying group. So these are the athletes that typically carry the ball. These were their sprint speeds. If they did the training program with a ball, they're in the light colored box. If they trained without the ball, they're the dark colored box. So when we look at these boxes, we look at the 10-meter sprint speed, we see that on average, they improved about 3 seconds in their 10-meter sprint speed after this training program. Okay, they improved again. As a percentage, they improved about 3% compared to their pre-test time, right? And we found that there was no significant difference whether they trained with or without the ball. Same thing that they see here is that they got, you do see a little bit faster time between the two groups, but it was not statistically significant whether they trained with or without the ball, and the same thing here. And we can see the same thing in the non-ball carrying group that, again, they did not have that change in time overall. So we did see differences and improvements in all of the subjects in all of the treatment groups. However, we didn't see a difference between the treatments or a difference between the type of rugby player. So this study would tell us that we can have them train with or without the ball, regardless of what they normally do in their position, and we will see similar improvements in their sprint speed. A second study that I found that examines performance of athletes, but in this case it continues to use a between-group factorial design with multi-factors, is this study where they examined knee strength ratios in competitive female athletes. One of the factors was sport, because they examined basketball players and volleyball players. Another factor was leg side, so left leg and right leg. And they had, again, measured the strength of their hamstrings and the strength of their quads and computed a hamstring quad ratio. So our dependent measure is hamstring quad ratio, which is a percentage, which tells us, again, what percent of force can they produce with the hamstrings compared to the quads, because the hamstrings are typically a little bit weaker than the quads. And what we found here was, and then, that one other factor, there was a third factor, was the speed at which they were tested for this strength. So they used an isokinetic testing device called the Biodex that tests the person's ability to generate force at various speeds. And what we found when we compared the left and the right legs, for instance, among basketball players, if we compare this leg to this leg, on average, their right legs were their hamstrings were a slightly lower percentage than their quads when we compared left to right within basketball players. When we look at volleyball players, we see a similar decrease when we compare the two. Meaning, again, we have a slightly stronger hamstring in their left leg when compared to their quad in their left leg, and so on. We also can do comparisons in a study like this between sports. So if we look at the right leg in the basketball players and compare it to the right leg in volleyball players, we can see that on average, the volleyball players were somewhat higher in their hamstring to quad ratio. So again, this study is just another example where they looked at multi-factors, in this case, 3 different factors, one of them with 2 levels, which was sport, one of them with 2 levels, which was side of the body, left or right knee, and then 3 levels on the third factor, which was speed at which they were tested. So again, we can see examples of factorial designs between group factorial designs really throughout the literature.